The recording is started. So we are discussing about what? We were discussing about Java data types. So yesterday we have concluded about the short data type, right? So whenever you are talking about data type, always consider the 4 points. Okay, the range, you talk about the range, you talk about the default value. You also talk about what? Whether it is a signed data type or unsigned data type. And at last you talk about the size in the form of bytes, right? Having said this, today we will start understanding the integer data type. Integer. So integer means int data type. So int is under part of integer. So let us try to understand the int data type in detail. Okay. So int data type. Int data. Okay. First thing. Focus here. This you will get a lot of questions in the int data type, and we will solve some problems, some tricky questions we will solve on top of int data type. Before that, focus here. So first point, I can say that it is a signed data type. It is a signed data type. Whenever I say some data type as a signed data type, always remember it is going to represent both positive numbers as well as negative numbers. Okay. And second point, the most valuable point is what? Its default value is 0. Default value is 0. Okay. And the third one is what? The size of the int data type. The size of the int data type is 4 bytes. Okay. And it is collection of what? It is collection of how many bits? 32 bits. 8 into 4. 32 bits. Okay. And last point. Okay. The values are values that you can store in the int data type is ranging from, it's a very big number, guys, very big number in the sense 214 crores, okay, 74 lakhs, right, 83,000, okay, 648. Okay, so 214 crores, 74 lakhs, 83,000, negative 640, negative of 214 crores, 74 lakhs, 83,648. You do not have to memorize these things. Okay, I will help you with the formula. Again, positive. The least negative value that it can store is this one, ranging from this value to the positive value, the maximum positive value. 214 crores, 74 lakhs, 83,000 again, okay, 647. Okay, this is the range. This is a range of what? This is a range of integer data type, int data type. But please ensure that you are not, allotting any spaces in between. Okay, just for the understanding, I have given some spaces. Okay, this is the range of int data type, and you can also find this range by using the formula. What is the formula that I have given? Just calculate number of bits, right? If you have number of bits in AND, and you can use that number of bits in this particular formula, minus 2 to the power of what? Minus 2 to the power of n minus 1, minus 2 to the power of n minus 1 to 2 to the power of n minus 1. Okay, and this the whole set again has to be reduced with 1 again. Okay, this is the formula to calculate the range of any data type, especially the integer data types. Okay, this formula is applicable only for the integer data types. You can use this formula for byte, you can use this formula for short, you can use this formula for int, you can use this formula for long. It is applicable. Okay? You do not have to memorize this. If you want, you can memorize this, or else you can use this formula. This is one of the way to find the range. The other way is, we know that by using what? By using the bit manipulations. By using bit manipulations, we can also find the range, negative to the positive. Right? Now let us see some problems on top of this. Let me take my notepad. Now I want you to tell the answers. Okay. Class A, okay, public static void main string array. I have a value like, so I want to display something in the console in the form of number. I'm taking system.out.println. Okay. So now you tell me what would be the answer. Everyone unmute and speak. Everyone. What would be 1000 is the answer. Anyone can say. Anyone with the eyes can say 1000 is going to get displayed on the console. Okay, so far so good. Now you see there is a takeaway here. Focus here. Let me save this. Okay, and it has to be saved in Java to a.java. Let me replace it. Let us compile this. Java C space. For the compilation, this is the command. Java C space a.java. For the execution, Java space 1000. Okay. So let me do something like now I will ask you one question. If I do byte a equal to 100, okay, and if I ask you to print if I try to access the variable name instead of value, if I try to access the variable name a, now you know that already the output is going to be 100 itself, because you are using the variable name which has the value 100. In this case also the output is 100. But what is happening internally is, what I'm trying to say is, the default data type that will be used in the system.out.println is the integer data type. Whatever the value that you pass, whatever the value that you're passing, okay, it will be treated as an integer. Example, let me take this piece of code, right? Okay, and we have two lines. Okay, the first line is what? First line is going to assign the value 100 to the byte, to the variable a. So there is a variable a, and the 100 will be assigned. Value 100 will be assigned to the variable a. What is the second line? Second line says what? Second line says, okay, so you're using system.out.println statement where you want to get access to the variable a, and again inside the variable a you have the value 100. You have the value 100 inside the variable a, but the system.out.println will choose to convert this from byte data type to integer data type. Internally, whatever the value that you pass, okay, or else if you are trying to access the value through the variable, you're trying to access the value through the variable, okay, you are accessing the value through the variable. So a is of what data type? Byte data type. It will not care. Okay, the system.out.println statement will not care at all. It will not care at all. What it will do? It will do the conversion. It will convert this to what? It will convert this to integer data type. Then it will print. By default, whatever the input that you pass in the form of integral data types, that will be converted to the integer, then the value will be displayed in the console. You may be just seeing 100, but if I ask you 100 is a data type of byte data type of or integer data type, it has been generated, it has been converted to integer data type, then it is getting displayed in the console. Okay, sir, if I pass something, if I do something like this, short, okay, again this short is a data type for the variable a. If I try to execute this, you will get the 100 in the console. Okay, but we don't see what kind of conversion is happening internally. Every data type, if it is the integer data type, by default it will get converted to integer. So this is short data type. A short data type will convert to integer, then it will get the value will be displayed on the console. We usually don't see, we just see the value, but The actual data type is what? Integer data type. So what is the proof? Okay, now let us do something like this. Okay, now I want to print something in the console, something like, let me print 1000 crores, 1000 crores, 1000 crores. So this is the 1000 crores, right? 100,000 lakhs. Yes, 1000 crores, 1000 crores. Okay, 1000 crores. This is 10,000 placeholder. This is lakhs. Yes, 1000 crores. Now, what will be the output? Can anyone tell me? Or you have no, you have idea, or you don't have any idea? What do you think the output is going to be? Any idea? Yes, no.
Same value.
Same value, huh? Okay, what about others? Now let us try to run this, huh? Let's try to run this. What it says? Integer number too large. Integer number too large. Look at this error. Look at this error. Okay, error says, okay, integer number too large. What does it really mean? Whatever the number that you are passing, it will treat it as an integer. But you have passed a number that is behind the range of integer. What is the range of integer? We have just seen that, isn't it? What is the range of integer? The range of integer is something like this, 214 crores. But what you are passing here, you are passing more than the range, more than the given range. So this is the proof that whatever the value that you pass, whatever the value in the sense, if you pass any number, that number, it is a whole number, that number will be treated as an integer. It will think, okay, this is the integer number. But when it tries to find the range, it is out of the range. That's why you are getting this error. So this is the proof that whatever the number you pass, that will be converted to integer. Then what? Then it will be displayed on the console. We do not want to get any error. If I don't want to get any error, I need to be very specific. When I say very specific, this is 1000 crores, right? It is out of integer range. I need to convince compiler in such a way that not take it as integer value, take it as long value. So the next bigger data type after integer. So this is the smallest data type when it comes to store the numbers. Followed by short is the second smallest, followed by int, okay, and followed by what? Long. Okay, so this value suits to the long data type, right? You want to be very specific to the compiler. How you can be very specific? Just add L. Now compiler will ensure that, okay, compiler will think we are forcefully using the suffix L. Suffix L means you are representing the complete number as the long data type number. It means compiler will not consider this as an integer. It says it thinks it is okay. Now if you perform the compilation, right, the compilation will be clear and you will get the output. In the output you don't see L, but it's your job to mention it, to mention the suffix as L after the number if it is behind the integer range. Why it is your job to mention L after the suffix, after the as a suffix after the number? Because by default the number that you are entering here will be treated as an integer. Compiler will blindly believe that whatever numbers that you are entering, it will blindly believe that it is an integer number. But you have cheated the compiler. Okay, instead of integer, you have entered a number that is out of the integer range. Right? No issues. If you are entering a number that is out of the integer range, it's also your job to ensure that you are adding a suffix L. Now compiler has no issues. If you are not adding suffix L, compiler will think, okay, this person is trying, it will always consider that, okay, it is an integer number. After compilation, it will come to know, okay, the programmer has made some mistakes. The programmer has cheated. Making sense? Are able to follow? Very simple. Just keep it in mind. You are entering a direct number here without the fractional part. It is a direct number. It can be a negative number or a positive number, but without the fractional part. Okay. Always, even if you enter some byte, even if you enter 100, it will be treated as integer. Or else let me do like this. If you do byte a equal to 100, if you do short b equal to 200, if you do integer c equal to 300, okay, instead of entering the direct value, even though you pass the variable name directly, okay, this will be converted to integer, then the output will be displayed as 100. Okay, if I ask you, hey, what kind of data type is this? Okay, literally it has got converted to integer, then the value is getting displayed in the console. Once again, and if I say we're passing b is a variable of short data type, okay, and the output is going to be 200. If I ask you what kind of data type is this 200, you should say, because it is getting displayed on the console, okay, after the conversion only it will be displayed on the console. Okay, after converting it to int, okay, it will be displayed on the console, right? And while likewise, if you do something like this, see, is 300. 300 is actually, it is an integer data type, so no issues. You will get 300 in the console. Since it is an int will be, no, there will be no conversion happening. It will be treated as int only. Okay, in the first two lines, so in the first two println statements, okay, the value may be of some other data type, but internally it gets converted to the integer data type. Then it will, after that it will be printed to the console. Making sense, everyone? In the interview room, you will get a question like this. Directly they will put a value like, okay, value like this, and they will check your intuition. So once 10 centers 1000 crores, they would ask you what would be the answer. What we would say, the answer is the same as the answer that you have in the system.out.println. But if you compile this, you will get a compile time error. Making sense till now? Are we clear till now, everyone? Say something in the chat box or unmute and speak.
Yes, sir.
Clear, right? Now let us try to do few more problems on this. Now let us check your knowledge here. Okay, there is a topic called typecasting. I will tell you after completing the data types. Okay, there we can find lot of tricky problems, what we call it as tricky interview questions. Okay, I am taking a byte. I am taking byte a equal to 100, short b equal to 300. Okay, I am doing what? System dot out dot println, okay, a plus b. What is the possible answer? Come on.
400.
400. Yes, 400. Now let me tell you something. Okay, this is the byte data type and this is the short data type. Internally, before evaluating the arithmetic operation, 100 plus 300, okay, this byte will get converted to integer and the short will get converted to integer, and the resultant value will always be in the form of integer. 400 will always be in the form of integer. That is why you're not getting error here. But if you see this, okay, when you do something like this, when you try to play with Javas, like the code that I'm writing now, short c equal to, okay, a plus b, right? Now what happens? Okay, now you are doing an indirect violation. Okay, now you tell me, if I do C, what would be the answer now? This is the compile time error, because you are evaluating here. You are doing an arithmetic operation upon byte and short. Okay, but this plus operator will always expect the integer on the either sides. If not, the resultant data type has to be of the integer type. But you are doing that violation. Violation is happening here. Violation is not happening, actually happening here. Violation is happening here. You will be getting compile time error in this line only. It will not even go to this line. It will not even go to this line, right? Now you tell me, okay, I have said these things already. Let's see who is going to answer this perfectly. Okay, don't think much. What is 10 plus, what is the answer? Just tell me.
20.
20 is the answer. 20 is the answer. Okay, now you tell me, what is the answer now?
Hello, 10.
Hello 10 huh? What about others? Any idea?
20 hello.
20 hello. Okay, so now let me tell you something. Okay, yes, people who say 20 hello is correct. Java C space a dot Java, Java space a 20 hello. So in Java, what is the scenario when you try to perform the arithmetic operation, especially by if you want to add two numbers, you can add it. But if you want to add two strings, also you can add it. It's just like this, guys. Okay. What Java says, Java has given a special powers to the plus operator. It has given some special powers. You don't see this anywhere, but in Java you see this. What Java says, you can do addition with two numbers, 10 plus. Okay. You can do that. First thing. Also, you can perform addition upon two strings, something like Java. Yes. Java. Second thing. In the first case, the output is going to be 20. So here the power of plus operator. Here what plus operator usually does is very simple. It will check each and every operand. Okay, this is the one of the operand and this is another operand. If two operands are the actual numbers, it will perform arithmetic addition. So it is very straightforward, right? And in this case, it will check whether this is a number or a string. The first operand is a number or a string. First operand is a number or a string, it is a string. And what about the second operand? Second operand is also a string. If the two operands are string, okay, what it does the concatenation. Okay, so in this case, this is going to do the addition operation. Okay, and if it finds two operands as the strings, it is going to do the concatenation operation. When I say concatenation, just joining two strings as a single one. Okay, it becomes Java. This is the power. Okay, now you tell me if I have 10 plus Java, this is a very typical case. Okay, and again plus operator, it will checks two operands. One is towards the left and second one is what, towards the right. Okay, it will be like, okay, one of the operand is a number and the other operand is a what, other operand is a string. What should I do? What should I do? Okay, and it has an answer for that. If at least one of the operand is a string, okay, without even thinking anything, just to do the concatenation. Concatenation means what? Okay, 10 plus Java becomes 10 Java. Okay, and the resultant value will be string always. Resultant value will be what? String always. Having said this, follow these three rules. This is rule number 1. Okay, and this is the rule number 2, and this is the rule number 3. If two numbers, direct addition. If two strings, concatenation. If at least one of the variable, what we call it as one of the values is a string, again concatenation. Okay, having said this, now you tell me what would be the output for this. Anyone?
20 hello 20.
40.
40 hello. What about any other answers? Good. Any other answers? Okay, let us do this. First I will show you the result, then we can start analyzing this. Okay, first let me show you the result. Okay, even I don't know what would be the result. Let us see. Java space here. What it says, 20 allow 10. This is the answer. Now we will analyze why we are getting this answer. Why Java is cheating us? What has happened with Java? Okay, why Java is giving us this? I have just said that when there are two numbers addition, even I have two numbers here. Why it is not adding this? Why this is not adding this? Right? Why it is not adding is, now focus here. This is also an interview question. Okay. Now see, these questions will be like very small questions, but if you observe, if you analyze, you will get lot of things. What is happening behind the scenes? Okay. The moment you give this code to the compiler or at the time of execution, what happens? Okay, the execution will start from left to right. Okay, how many operators are there? Only one. There are only one operator which is repeated for 4 times. Can I say plus the operator is getting repeated for 4 times? Yes or no? So you have plus operator. It is repeated here, here. So it will check the operator from left to right. If from left to right, it has found one operator. Okay. So it is going to consider the other, consider the operands. So this is the first operator, which is a plus operator itself. What are the two operands? You have 10 on the right side and you have 10 on the left side. Okay, evaluation will be performed. First, it will evaluate these two. After the evaluation, you get what? You get 20. 20. It is what? It is passing the rule number 1. 10 plus 10, 20. Right? Again, what is the remaining? Okay, you have the remaining things like plus, hello, plus 10, plus 10. Okay, now do the same thing. Okay, the execution will start from left to right. Okay, now find how many operators are there. Only one plus operator, which is repeated for 3 times. 1 time, 2 time, 3 time. Okay, take this. Take the first operator, which is what? Plus. Okay, there are 2 operands. Hello, on the right side, and you have something like 20 on the left side. What is the rule that I said? If at least one of the operand, what do you really, I don't know if I'm pronouncing it correct or not. I'm saying operand. Operand is the values, okay, and operator is the actual symbol. Okay? If at least one of the operand is a string, okay, the resultant value has to be what? The resultant value has to be string. Yes or no? So it becomes 20 plus hello becomes 20 hello, which is a string. It will be converted to a string. Now this 20 is not a number anymore. The combination of 20 hello becomes 20 hello, which is a string again. What is remaining? Again you have plus 10 plus 10. Okay, again the execution will be happening from left to right. Okay, it has to identify the operator. Okay, from left to right, it has identified the operator. Take that operator plus. Okay, and what is the other two operands? You have 10, right, and you have 20 hello. 20 hello. Okay. If you see this, again one of the operand is a string. If one of the operand is a string, concatenation will happen and the resultant value will be a string again. Okay, this becomes, after the evaluation, will become like 20 allow 10. Now what is the remaining again? 20 allow 10 plus what? The another 10. Okay, the execution will start from left to right. Okay, so after doing evaluation, right, again there is only one operand left. If you consider this case, okay, one of the operators, one of the operand is a string again here. This is a string. String plus number, again string. Concatenation will happen. You get what? 20 hello what? 10. Making sense? Why did we get this? Everyone are able to understand? Okay, so this is called as plus operator. Is a very special operator in Java, which is going to do addition if you place numbers, if the two operands are number, as well as concatenation if two operands are strings, and again concatenation if at least one of the operand is a string. Okay, and the execution will be evaluated from left to right. Everyone, are you getting this? Yes, no? Say something. Say something in the chat box. Are you getting? Any confusion? You want me to repeat this again? Prasanna, Purnima, making sense? Okay, you will answer this question, then I will understand that you have understood this. Huh? You have to answer this question. If I am asking you once again, answer this. Post the answer in the chat box for this. If you are answering this, I will post the answer in the chat box, or if you can tell this.
Java 10.
Java 10, hello?
Hello, 10 hi.
Okay. So now I think you have understood this. 1 minute. So it is not the error. 1 minute. This error something. Okay, I have missed the plus symbol here. Okay. Okay, Java 10, allow 10, 9. So everything is a string now, because there is no way for the there is no way here to perform what? To perform the arithmetic operation, because you don't see there are recurring consecutive, there are consecutive numbers, there are no consecutive numbers, or else I can say that there are no operands, there are no operands of same type, or there are no operands of numerical type. That's the reason why everything is getting concatenated. Okay, from the left to right, concatenation is happening. There is no scope for the numerical operation, right? So having said this, let us see few more examples here. Okay, I think you will be able to answer the questions going forward. Okay, now you tell me. Okay, let me remove this. Okay, integer bill equal to 100. Okay, static bill integer bill. Okay, now what is the answer, guys?
One zero one.
101. Very straightforward. The answer has to be what? 101. Because you should observe, okay, even though this looks very simple, there should be an observation. Find the variables. Okay, so you have a duplicate variable, so this is not considered as a duplicate, because this is considered as the reassigning, the concept of reassigning. You remember yesterday I was telling you D, okay, and I, DIA. So here the declaration and initialization are happened. Declaration and initialization on the same line. Okay, here this is a concept of reassigning. Okay, and here is the concept of what? Accessing. This DIA is applicable. This DIA is applicable only in the method. Can I do DIA in the in the class variables, in the class level variables? If I do DIA, let us see if I am doing. Okay. See, I am just trying to do what? This is the initialization. This is a declaration. I am trying to do initialization in the other line. I am trying to do the initialization in the other line. Let us try to access the bill variable and let us see the output. Okay. What it says? Identifier expected. Okay. If you want to do outside in the class level, if you want to apply DAK, that is not possible. DA is applied only inside the method, not in the class. Okay, if you do not declare, you just declare this, and if you are not assigning any values, that's why there is a concept of default value. That's why there is a concept of default value. Okay, for the integer data type, what is a default value? What is a default value? If you are not assigning it, right, and if you are placing the variable outside the method, inside the class, this becomes the class level variable. For the class level variable, it is not mandatory. It's not even mandatory to do what? Not even mandatory to do what? To assign the value. If you're not assigning the value, the default value will be coming into the picture. Okay, now you said, now you tell me. So now you tell me what will be the output. Error. Because even though you have declared here, even though you have performed declaration, you did not initialize it. Variable is not initialized, right? It is variable bill might not have been initialized. It means you did not initialize it. I is missing. Okay, but you are trying to do accessing. Okay, since there is already the bill, there is already the variable bill inside the local, this will definitely consider the local variable. It will not jump to the class level. right? Now you tell me this is valid or invalid. We have discussed these things yesterday, so today we are discussing this in a different way. That's the only difference. Is it valid or invalid?
Valid, but nothing else.
Yes.
It will compile, but no result.
Yes. There will be no compile time error. There will be no runtime error, because you can just declare it. You can declare the variable in the method level. You can also declare the variable in the class level. Okay. But always remember, when you are trying to access a variable inside a method, you are trying to access a variable inside a method, please ensure that that variable is initialized. Please ensure that that variable is D is there, A is I is initialization is missing. Now you will get error. But if you are not accessing it, there will be no issues. But if you access it without the initialization, you do declaration, if you are accessing it without the initialization, then the compiler will get angry. What compiler will say? What it will say? This is the error that it is going to be. This is the things. Now I think it is making more sense if you see this, right? And we have understood about int data type. Let us also understand about the long data type. Okay, very easy. Long data type is also very easy data type, right? Long data. Okay. What are the problems that I can give? Before giving the problems, let's talk about the size. The default value of long data type is 0, but what they are usually saying is the default value is not 0, the default value is 0L. Where is the proof? But you don't see the default value for the long data type with the suffix L. Okay, so to understand this, I take this data type as long data type, right? Let me remove all this. If I execute this, okay, I need to see the default value. But if you see the default value in the console, it will be just 0. Okay, L is not getting appeared here. L is not getting, suffix is not getting appeared here. Even though whether it is appearing or whether it is not appearing, during the execution it will be removed. But internally, when someone is asking what is the default value of long data type, should answer it is 0L, not 0. Okay, for the byte, for the short, for the int, it is 0. Okay, but when it comes to long, it is 0L. The suffix is very important. Suffix is very important. Second point. Okay, then let us talk about it is a signed data type. Signed data type. And the third one is what? I can say that the size of the long data type is what? 8 bytes. When I say 8 bytes, if I ever add to convert this to the bits, 8 into 8 is what? 64. It is a collection of 64 bits. It's or a group of 64 bits. So the minimum value is going to be very minimum, a very big number. Okay, let us try to check this in Google. Okay, usually you don't remember, you don't memorize this. Okay. Long data type range in Java. Okay, so this is the range. Okay, I don't remember this. I don't memorize these things. Okay, but I know that it is going to hold a very big value. This is the minimum value, the maximum value. Okay, and the fifth one is, what else we have? Okay, the formula is same for long also, but how to calculate this? Minus 2 to the power of n minus 1 to what? 2 to the power of n minus 1 minus 1. If you have time, you can do this. can calculate n is number representing number of bits. Yes. Now I think you can do all the problems by using this all the 4 data types. Now let us try to understand something here. Okay, now you tell me long a equal to print a. What is the output now?
Thousand.
Okay, 1000. Now if I suffix this number with L, what is the output now? Let us see. Okay, so what is the conclusion that I can give? If you are using a long data type, if you want to be very specific, if you want to be very specific, okay, the value is of long type. You are being very specific here. This value is of long type. You just suffix it with L. Suffix it with L. So that this is a good programming practice. Right? And something, for example, if you have something like byte a equal to 10, you have something like short b equal to 20. Okay? You have something like int c equal to something like 30. For this, you don't require any suffix. Based upon the data type, it is very much understandable. But for the long data type, even though you are keeping the suffix, if you're not keeping the suffix, no issues, but you are just being very specific. L means representing a long. Because by looking at the number, okay, anyone can assume that it could be int type. If you want to be very specific, you have to say that it is of long type. In the future, what happens, there will be, for example, in the stock market, you are investing 1000, this is your amount. Okay, after 100 years, or let us say after 10 years, okay, the price would increase. Okay, the A has to hold a value that is longer than the long data type, longer than the integer data type. So it may start with a small number, but in some fraction of months or in some fraction of years, I mean, after some years, this number it would never remain as 1000. It would be increasing every year in a cumulative way. If you have such requirement starting from 1, okay, and if it keeps increasing every day exponentially, then you have to use that variable with the data type called long data type. That is very much of it. There are some cases where you will be in a situation, the initial value would be something like 10, but it's your duty to assign it to the long data type, because this 10 would be increasing. This 10 would be increasing just like this. And a plus, every month this 10 keeps increasing, or something like every month this 10 keeps get multiplied with 10,000. The variable a has to be strong enough to accommodate the changes that is happening, isn't it? It will be strong enough to do what? Accommodate the changes that is happening. Now you see a equal to 10L incompatibilize possible logic conversion from what has happened here. Okay, so I have declared this variable once again for the second time. Making sense? This is not going to be fixed. It keeps increasing. When you have such cases, you need to use for long data type. Well, let's do some programs here. Let us try to understand something here. Just tell me whether it is valid or invalid. I have some values. I have some values like 1000. Okay, this is one. If you take it as 100, if you take it as 10,000, okay, the two bigger numbers. Okay, if I have to choose integer, byte a, short b, integer c, long d. Okay. Now you tell me valid or invalid. You're placing 100 here.
Valid.
Valid.
This one is also valid. Yes or no? This one is also
Yes.
valid. This one is also valid. But which one would be appropriate? If you ask me, which one is very much appropriate? If you assign this value 10 to the byte, let us assume that all these are constants. So they will not get any changes. Think like that. If all these values are constant, what would be the appropriate place for this value? I mean, what would be the appropriate variable for this 100? Can I say A is appropriate variable for this 100? Because it would remain same forever. So you can choose the minimum data type. Okay. Now if I take this, now you tell me whether it is an appropriate or inappropriate. Is it appropriate or is it okay? It is okay, but is it recommended? Not recommended. Why not recommended? You have an option to, because it is a constant, it is going to remain same forever. In that case, you can go for int. But again, there is another option. You can go for short. Because short is good enough to store the value 10,000. Very much appropriate. It is not like it is wrong when you do it when you store the value to the variable of long type, you store this value to the variable of int type. But it is not appropriate. So that's why you do it here. And if you take this, I'm saying this is not I think ones, tens, hundreds, thousands, 10,000. 10 crores. Okay, 10 crores you can choose either the long type or it can be chosen to be in the integer data type. But which one is appropriate? This one is appropriate. So you can save a lot of memory because you are dealing with constants. So since this cannot be accommodated by byte, short or integer, you can choose this. Okay, but if you have any value which is variable in nature, variable means which is not a constant, you think logically and you should understand which data type will suit this variable. Which is the data that is going to suit this variable. And that's all about the data types. I don't think let me introduce one thing, okay, and you will understand this. I will just introduce this. We will understand this in the typecasting. Okay, now you tell me, guys. If you know, you can tell me. So this is something like 200 crores. Integer A equal to 200 crores. Integer B equal to again 200 crores. Okay, 1, 2, 3, tens, hundreds, thousands, 10,000, lakhs, 10 lakhs. Okay, 200 crores. Okay, and integer C equal to A plus B. I want to print C. Can you tell me what would be the answer? This is 200 crores. 200 crores. Okay, this is also 200 crores. 200 crores. What would be the answer? 400 crores? Yes, no? What is the range of integer? Now I will show you the range. Range is 214 crores. Negative 214 to positive 214. Now, okay, this is acceptable here. I mean, you can store 200 crores to the A variable. You can also store 200 crores to the B variable. What I am doing, I am trying to store A and B. I mean, the arithmetic operation of A and B is going to give the 400 crores. I am storing that to the C variable. Okay, what would be the answer? Very straightforward, right?
Yeah.
Error. What about others? Let us run.
Error.
Okay, don't get any confusion here. Okay, we are compilation able to be successful. You are getting some garbage value here. Okay, this concept is called as what? Typecasting. Do you remember? You remember in the beginning I said the default data type for the whole number is the integer data type. Here you are getting some garbage value because I said now integer plus integer, okay, byte plus short is going to be int, short plus long is going to be int, everything is going to be linked. But here you're doing what? You're doing int plus int is going to be int only, but there will be some values will be overflown here. Some values will be overflown here internally. This is a bit manipulation concept. This concept is called as what? Typecasting. You call this as typecasting. Right? You call this as what? You call this as a typecasting. Right? Having said this, okay, what is happening behind this? Okay, let me help you to understand this. Okay. I said no, integer is also a very special data type, because by default the system.out.println statement will convert everything to the integer. Okay. So basically this range is accepted and this range is also accepted. Okay. It is within the range, it is within the integer range, but when you calculate, it is going out of the range. It is going out of the range. Okay. But what you want, what you are doing, even that is going out of the range. Okay, this plus the operator, I was telling you, whenever you are using a plus b, let's say that whenever you are doing an arithmetic operation, okay, when you are using a plus operator, it will expect integer on both sides. That case is valid here, no? That validation is perfect, right? So a is also an integer, b is also an integer. So compiler says, okay, if you are using a plus operator, I will allow only to do the arithmetic operation if the two operands are integer type. As per the compilation we are doing. As per the compilation, this is valid, this is also valid, and a plus b also valid. As per the compiler, it is completely valid. Then what compiler will do? Okay, the number is what? Now the combination of a plus b is going to be what? 400 crores. It has to find a way to what? To avoid the compilation error. It has to find a way to avoid the compilation error. Internally, it will do typecasting. Internally, it will do typecasting and it will give you a value. The question is how we are getting this value. That we will understand in the typecasting concept. How we are getting this value, that we will understand the typecasting concept. Right? Remember this rule. Rule is what? For the plus operator, both the operand has to be integer type. If not, the resultant value has to be integer type. If that is getting satisfied, there will be no compilation error. But value wise, you might be seeing a lot of errors. Value, as per the value, it is error, right? 200 crores plus 200 crores is 400 crores. What it is giving? It is giving some garbage value. Giving some garbage value. In order to understand this, that's the reason why I've explained you about the bitwise operators. So bitwise operators will help us to understand why we are getting this kind of value, what is happening behind the scenes, okay, how the bit manipulation is happening. Right? Don't keep any confusion. So the takeaway is always remember byte plus byte is integer, should be integer, or byte plus short should also be integer. Short plus byte should also be integer. Okay. And again, int plus int must be integer. Okay. This is the rule. If this is the rule. If this rule is satisfying, no matter what, compiler will do some modifications inside to throw the to throw some garbage value according to the bit manipulations. That is the future topic. So that is the future topic. We'll understand. Not future means after 3 classes you will get to know about this. So this is also a popular interview question. By blindly you would say that they will ask you, is it okay, or you will get the compile time error. Directly you will say you get the compile time error, because you will argue with the range. Sir, what is this? The range is out of the range. It should be compile time error. After the execution, you will find it is not giving any error. You will get this value. They will not ask you for this value. They will ask you whether you will get the compile time error or not. Okay, so this is satisfying this rule. Very simple. This is satisfying this rule. If this rule is getting satisfied, no issues. Here you can give the value. Here also you can give the value. Here also you can give the value. But in this case, you cannot give the exact value, because internally typecasting is happening and a lot of bit manipulation is happening. That things you will discuss in the future. Okay, one more thing you have discussed today about the plus operator. Okay, it is an overloaded operator which can be used for what? Which can be used for the addition as well as concatenation. Plus is a very special symbol in Java. Okay, then what else we have? That's it about long data type, and that's it about int data type. Tomorrow we will try to understand the Boolean data type, very interesting data type, Boolean. Then we will see char data type, then we will see float and data. With this we can complete data types, and we can start discussing about typecasting. So that's all from my